When you're trying to remember which method you're using here, eliminate means to get rid of something. Substitute means to take something out and put something of equal value in its place. So I want to, and this method in some books is called the linear combination method because I'm going to add these two equations together. When I add them together, I want to eliminate or get rid of one of my variables. Now these two equations are set up so that that's already possible without doing anything first, because positive 4x minus 4x or positive 4x plus a negative 4x is 0, so my x would be eliminated. Remember, you're adding things together, so you need opposites. If this is a positive 4, this has to be a negative 4. If they're both positives and you add them together, you're not going to get 0 for your coefficient. So then I have a positive 2y and a plus 6y is an 8y. Negative 8 plus 24 is a positive 16. Then when I divide both sides by 8, I have y equals 2. Now, I don't have quite the easy way of solving for the second variable as I did when I did substitution. What I need to do is just take one of these equations, and it doesn't matter which one. I'll get the same answer either way if I do this correctly, and substitute 2 in place of my y. So 4x plus 2 times 2 equals negative 8, means 4x plus 4 equals negative 8. I'm going to subtract this constant from the left and from the right to eliminate the constant. So I have 4x equals negative 12. Then when I divide by 4, x is negative 3. So I get the point negative 3, 2, which means if I graph those two lines, they intersect at that point. Now here, I don't have opposites. If I add these together right now, I'd get 7x plus 2y equals 52, which is a true statement for this system, but it doesn't help me to solve it at all. So I can't always just add these things together to begin with. I have two options here. I can say 5 and 2 if I want to eliminate my x. 5 and 2 both go into 10, so I could multiply the first equation by 2 to get a positive 10x, and the second equation by negative 5 to get a negative 10x. But when I look at the y's, 3 and 1 both go into 3, and this first one's already 3. So since it's a plus or positive 3, I want the second one to be a minus or negative 3. So I'm going to have to multiply it by 3 to make that happen. And that's going to give me 6x minus 3y equals 54. Everything in this equation gets multiplied by 3. Now all I'm going to do is just move this equation down so the two equations that I'm adding together are right next to each other. 6x and 5x is 11x. Minus 3y plus 3y is 0, so I just eliminated my y's. And 54 and 34 is 88. When I divide both sides by 11, I get x equals 8. So my ordered pair is going to be 8 something. Now, take either one of these two equations. Again, it doesn't matter. It could be the first one or the second one. And I now know that x has a value of 8. So I'm going to substitute that in and then solve the equation I get. Well, 5 times 8 is 40. Bring down my plus 3y equals 34. I'm going to subtract 40 to eliminate that constant on the left and move it to be with the constant on the right. And I get a positive 3y equals negative 6. Then when I divide by 3, y equals negative 2. So the point 8, negative 2, if I graph those two lines, that's where they intersect. Now, again, this one, if I add them together right now, neither my x nor my y would be eliminated because they don't have opposites. But I notice that 2 goes into 6. If this is a negative 6x, I want the first one to be a positive 6x. Since it's a positive 2, I'll multiply by 3. That gives me a positive 6x plus 9y equals positive 42, again multiplying everything by 3. The interesting thing that happens here, though, negative 6x and positive 6x is 0, so my x is eliminated. Negative 9y plus 9y is also 0, so my y is eliminated, and that's how the equation is just 0. And then 10 and 42 is 52. So I eliminated both of my variables, and I get this statement that can never be true. This is a no solution system. If this ended up being 0 equals 0, it would be an infinitely many solutions system. But this one is no solution. which means if I graph those two lines, they end up being parallel and they never intersect. Now this last one, 5 doesn't go into 3, 3 doesn't go into 5, and they're not opposites. 4 doesn't go into 9, 9 doesn't go into 4, and they're not opposites. So I'm going to need to multiply each equation by something, and by a different something to create opposites. I could say 5 and 3 both go into 15, and multiply to make this a positive 15x and this a negative 15x. 4 and 9 both go into 18, or 36. So actually, they don't both go into 18, sorry, 36. So I could multiply the first equation by 9 and the second one by 4 to make this a plus 36y and this a minus 36y. I tend to, a lot of times I like to work with the ones that are opposite signs to begin with, but in this case the 5 and 3 are much smaller numbers than the 4 and 9, so I'm going to work with those instead. So I'm going to multiply everything in the first equation by 3 to make this a positive 15x, everything in the second equation by negative 5 to make this a negative 15x. So going from the first equation, I get 15x plus 12y equals negative 90. The second equation becomes negative 15x plus 45y equals positive 90. Again, everything gets multiplied by negative 5. When I combine these now, I end up with 57y equals 0. At this point, some people said no solution. There's a solution. I didn't eliminate both variables. To get the y by itself, I just divide both sides by 57, and 0 divided by 57 means that y is 0. If y is 0, I get the equation 5x plus 4 times 0 equals negative 30, which means 5x, 4 times 0 is just 0, so 5x plus 0 is 5x, so 5x equals negative 30. And then when I divide both sides by 5, I get x equals negative 6. So these things actually intersect on the x-axis at the point negative 6, 0.